Have you ever wondered that when you ask a question to something like a ChatGPT or Gemini, the word thinking that comes? What does thinking actually mean? Well, there's a large reasoning model behind the scene who is actually trying to understand your question and craft the right response for you. In one of my previous videos about AI agents, I spoke about what does this reasoning actually mean, and are these models actually reasoning? I spoke about what is the difference between human thinking and machine thinking. So if you have not watched this video, I request you to do so, because a lot of things will get clarified from the previous video itself. In this video, we are going to understand large reasoning models, all LRMs, a little bit more in detail. But before we do that, if you have not subscribed to TestMu AI's YouTube channel, I request you to do so. There are some great contents created by some great content creators and techies across the world. Let's get started with this video. Well, the traditional large language models has this projectile prediction, or whatever you want to call it. What I mean is, in my previous videos also, I spoke about the statistical pattern matching, with which they basically try to have this reflexive token generation where they generate one token after the other to complete the entire statement until they believe that they have actually answered your question, right? And you have an input and immediate output. For example, if you go to Hugging Face and take any large language model that is hosted there and ask a question, what is 1 plus 1? Immediately you'll get the answer 2, because they're looking for immediate outputs. Well, there is one more type of model available, which are called LRMs, or the large reasoning models, who think before they talk. They work similarly as large language model, but their internal architecture makes them plan, evaluate their steps, and then answer, right, at a model level. Which means that whenever you ask a question, they try to understand your question and try to figure out a plan, and then they weigh, like they put specific weights to those steps that they have created, that to my output, how much this step being successful is essential, right? And they do that, and they use this sandbox. So basically, input comes and output that you get to see. Between this, there is something called a thinking box, where they are actually doing exactly what LLMs do. They are actually generating an answer for your question, but you don't get to see it, or we don't get to see it. What they do is they create an answer, and then they evaluate that answer based on the steps that they have basically came up before, to understand whether it is good enough to show to user or not. And they only show it once they completely believe that this is exactly what the user is looking for. So in my previous example, when I said 1 plus 1 equal to 2, if you go to a language model, it will give you that. If you go to a large reasoning model, let's say DeepSeek, and if you give something like 1 plus 1, what is 1 plus 1? And you see that thinking process, because DeepSeek provides that, you will see that it is thinking a lot before it is going to say that, hey, the answer is 2. Now, the reflex versus reasoning is one of the primary differences between a large language model and a large reasoning model. What I mean is that, let's say you have a question that you have asked, which is basically write a fun post for social media, right? And LLM will probably go ahead and quickly write that post. It may not be a straightforward question like this. You probably gave some context that, hey, I just visited this museum and I want to write a post for my social media. The same task, when you give to a large reasoning model, it will first try to understand your question a little bit further. You said social media, but is the social media Twitter? Because then I am bounded by characters. If this social media is Instagram, then the user base I know, I have to make sure that I cater to that level of users who come to Instagram. Or if it is LinkedIn, then I know I'm dealing with more professional network of yours. And that's where there's a big chain of thinking that large reasoning models do before they basically come up with a question. And you can ask many such complex questions which requires complex thinking, like for example, trace cash flow through shell companies or something like that, right? So now, how these models are actually built, right? What are the steps to build a large reasoning model? Well, every large reasoning model is actually built at the top of LLM, right? And it goes through the same steps. So there is a massive pre-training that happens where billions of web pages, books, and codes, etc., are ingested as a training data, and then we try to create a broad knowledge base with entity relationship or weightage value of all this data in the form of vectors, vector embeddings, to basically create an artificial neural network. The second step is where the LRMs kind of becomes a little bit specific, where we the architecture shows them how to work. Like, for example, the architecture is designed in a way where we say that, okay, you need to have an initial thought process, you need to come up with step-by-step way to basically cater to the question that is asked, and then provide the final conclusion. So in this fine-tuning, in this fine-tuning of the created LLM, there are a lot of logical puzzles and math used to understand whether this model is actually trying to understand the question at hand, right? What is the initial thought process? Then there are chain of thought, or the answer keys that are given, actually evaluated for those large reasoning models to understand how they are thinking about this problem. And that's what I'm saying. So if you for the 1+1, what is 1+1 to DeepSeek, you sometimes see that before it says it's 2, the chain of thought kind of says that, hey, usually 1+1 equal to 2, but why the user is asking me such a simple question? Maybe it's a trick question, maybe it's binary, and then in that case 1+1 is not equal to 2, right? So that's chain of thought that is also being evaluated or being checked, and then the model learns these steps and not just answers, right? It doesn't jump for your answers. It tries to understand what it would take, what are the things that it need to do to come up with the right answer for your questions. And then the step comes, which is reinforcement learning or and process rewards. So now, after all these steps are created, that's logical step 1, logical step 2, etc., there is a RLHF happens, which is reinforcement learning with human feedback, which basically looks at the steps, and which are basically human, who basically says plus thumbs up or thumbs down for each of those steps, right? The second thing, sometimes we use smaller AI models to grade these processes, right, or these steps, right, whether just to judge that whether the LRM actually came up with right step or not, right, and these are called process reward models. Ultimately, the goal is same. How can I maximize the logical coherence, right? How logical I can be before I actually give the answer to the user. Now, beyond these, you can also use something like a distillation. So distillation is a process where you have a large teacher model whose thoughts are actually given to the student model, which is under development right now. So the teacher model, for example, we look at how this teacher model actually or actually thinks about a specific complex task. So we give like 15-20 different complex tasks to this teacher model, and whatever or however this teacher model is actually thinking is replicated in the training architecture of the student model as well, and hence by embedding those steps as well for the student model. Now, the question here is that your LRM is built, but when it comes to execution, the thinking is going to cost you. And it costs you in terms of GPU, it costs you in terms of time. So what is that cost of thought? Right? What is that test time compute? How much compute allowance you want to allocate for what type of use cases? And in this case, for example, you can write a caption, which is pretty fast. You give smaller compute allowance, but let's say here is my logs for all 5xx errors that happen in Grafana. Can we analyze those? That will probably be higher compute allowance, because you know that you need deep thinking in this type of cases, right? And if you have used the APIs of these models, you will see that in the payload of the request, there is a optional parameter called thinking budget, or sometimes, and for some models it is just thinking, where you have to say how much token you want to provide for thinking, how much you want it to think. It can be customized from the API level as well. So what is the upside of LRMs? The accuracy, right? And the autonomy. When I say accuracy, what I mean is basically, because of this architecture that I explained before, there are a lot of internal verification happens before the output is actually given to you, right? So you are going to see a lot more accurate answers compared to a large language model. Then the prompt engineering is lesser, which means that, you remember when ChatGPT and everything came up, a lot of people started saying that, hey, this chatbots are always giving me generic answers. And that is because we are asking generic questions to large language models, right? And that is where the concept of prompt engineering came in, where we say that, okay, you have to say something like, you are the finest finest language teacher in the world. You have to teach me French, and this is how I like to learn, this is how I want to learn, and this is blah blah blah. You create a big prompt. Well, in case of LRMs, there are a lot of things that is taken care behind the scenes. So your small prompt can give you the best results that you're looking at. You don't have to be that methodical anymore when you try to ask a question to a chatbot which is built using a large reasoning model. And again, you don't have to ask it things step by step, which you used to do when it used to make errors like how many R's are there in the word strawberry. That's a famous example. What is the downside? Finance. Like you need to understand which use cases in your organization is going to require large reasoning models. You cannot convert every use case or every chatbot which used to use large language models into LRMs, because these are going to cost you in terms of time. Let's say you have a customer facing chatbot where the customer is asking that, hey, I just need to know what happened to some of my orders, right? And you want to give an analytical answer to that. You cannot use LRM because the customer is not going to wait for you forever, right? In that case, you use LLMs. So you have slower replies. You need to provide that thinking time to these large language models, and hence you have to choose your use cases very, very carefully. It uses a lot of energies because of the thinking process, because of the complex architecture that we just spoke about, and hence if you are not cautious, you might end up with a large cloud bill, right? Let's say you have 7 use cases and you convert 7 use cases to LRMs, which basically doesn't need reasoning. You will end up with a bigger cloud bill. Now the question here is that whether this do you need a direct answer, or you need this deliberate thought that should come to your use case. And most intelligent models benchmarks are basically crossed by this large reasoning models. We spoke about MMLU, or massive multitask language benchmarking, that in our previous videos. The LRMs scored the highest in these, right? So this deliberate thought gives them this stature into the world of large language models. They are at the top. They are those people who are basically highly they act like SMEs. They'll act like PhD students because of this thinking process. But the question here is, do you actually need for your use case or not? So I want to leave this video here, but I want to leave at one thought. For all use cases that you have, or that you have been using LRMs for, is accuracy worth the wait, right? You need to answer this question whenever you are trying to come up with a use case where you need to spend the money to basically get a large reasoning models, money or time, both, right? So I think I want to end this video here, but I hope this gives a little bit more deeper. So if you combine with my previous video where I spoke about what is reasoning, and a specific this one with LRM, I hope this gives you that foundation. and you might want to relook at your AI use cases which are using LRMs. Thank you so much for your time, and I'll see you in the next video.